video, let us see how to implement linked list in Python. So before we implement the Python code, we're gonna first understand how a linked list will look like. So this is how a linked list will look like. It has collection of nodes. Each node has two parts. The first one is the data part and the second one is the reference to the next node. Here we have 5 as a data part in the first node and it refers to the next node here. The next node means the neighboring node and it goes on. The first node is called the head node. You can see that on the screen. The last node is called the tail node, which don't have any next part here. You can see it points to nothing. Using this tail node only, we can understand that the linked list is entered here. So let us see how to implement this linked list in Python. Let's get started. First, we're gonna create a class now. Class node. Using this node only, we're gonna create the individual node. This will contain two variables, data equal to none and the next is also none. After that, we're gonna create the constructor now. For that, we're gonna create init method. This will take two parameters, self and the data. So this video is only for those who understand the class and object. If you don't know class and objects, then watch any tutorial and continue ahead the video. We're gonna set the self.data equal to data. Now we have created the code for creating an individual node. Let me change the next to next node for our better understanding. Now to run this, we're gonna open up your terminal and type python -i main.py. Here the -i stands for interactive shell. We're gonna get a interactive shell where we loaded all the class. Here we got our shell now. First let's create a node n1. This is our starting node n1 equal to node of, we're gonna pass a value of 10. Now we have created the node. If we type n1, we get a object which don't help us. For that, we're gonna return some meaningful information. To do that, we're gonna create REPL method. This will take self parameter. Here we need to return some message now. Return, we're gonna use the f string now. Node data. When we access the object, we're gonna get this message. Node data and self.data. Let me exit this current terminal now. Python -i main.py. Let's create the node again, n1 equal to node of 10. Now if we access the object, we get a useful information, node data of 10. So this is the usage of using the REPL method. Let's create another node now, n2 equal to node of 20. Now let's change the next part of the first node to n2. This will point n1 and n2. Now if you access the n1 the next node, yes, you can see it says node data 20. That means we have successfully changed the reference of the first node to the second node. Now this is the code for creating a node. Let's actually work on the linked list. Class of linked list. We're gonna create a constructor now. Def, we're gonna create the init method. This will take one parameter self. First, we're gonna set the head. Self.head equal to, initially it will point to none. Later, we're gonna change that. First, we will create isEmpty function. This function is just return true or false. Return self.head equal to none. Based on this, we're gonna get a true or false. After that, we're gonna define size. This will just return the length of the linked list. For that, we're gonna create a temporary variable current equal to, this will point to the self.head. We're gonna get the starting node of this linked list by using the self.head and set it to the current variable. After that, we're gonna define a count variable to 0. While we have a linked list, we're gonna increment the count value by 1 and also change the current equal to current.next node. We're gonna move the current to the next node. Finally, we're gonna return the count variable. Return count. So let's test these two functions now. So let me exit this current screen, like exit function. Let me create the screen. Let me maximize this terminal and type python -i main.py. Let's create a node now. n1 equal to node of 10. Let's also create a linked list object, L equal to linked list. We're gonna point the L.head equal to n1. We're gonna set the head node to n1. If you get the size now, you can say we get a node of 1. That means we have a 1 node in the linked list. Let's create another node now, n2 equal to node of 20. Let's change the next of n1 to n2. n1 dot next node equal to n2. Now if you access the L dot size, you can see we get a 2 node. Now we have implement the size and isEmpty functions. Let's add a new function now, add. Using this add, we're gonna add the node directly. This will take 2 parameters, self and data. We're gonna create a new node here directly. New node equal to, we're gonna call the node class and pass the data that we get from the function. Here we're gonna set new node dot next equal to self dot head. We're gonna change the next part of the new node to the head. Then self dot head equal to, we're gonna change the current node as a head node. So this is the code to add a new node. Let's try to test that out. For that, Python -i main.py, we're gonna create a object for linked list. L.add, we're gonna add 10. If you get the size, you can say we have a 1. Let's also add another node, L.add 20. If we get the size now, you can say we get a 2. That means we have created the 2 nodes. But when we access the L, we get a linked list object. Here also we're gonna define the REPL method, which we're gonna return the useful information. Def REPL, we're gonna return the REPL method, we're gonna return linked list in a nice format. For that, we have created a current variable that point to the head node now. While current, we're gonna check if current equal to self.head. If current is head, that means we're gonna append the current as a head node. We're gonna use the F string now. When current is head, we're gonna set current as a head node now. L is if current dot next node equal to null, that means it is the tile, right? So we're gonna append. Here also we're gonna use F string, that means it is a tile node. Tile is also was current dot data. In the L statement, we're gonna just return the nodes dot append. We just gonna append the current dot data. So this code will nicely return linked list in a nice format. In the next part, we're gonna change the current equal to current dot next node. So let's save this file and see how the objects. So this is the code to return linked list in a nice format. Finally, we're gonna separate the nodes by arrow and use the join function to join the nodes. Let's save that and let's run the file to test it out. Python -i main.py. Let's create a linked list object now. L equal to linked list. Let's add a node now. L.add, we're gonna add 10. Let's also add another node 20. Let's also add another node 30. Now if we see the size of this linked list, we see easy. Now if we access the L, we can see we get a nice format, head 30 and tail 10. That's why we have created this code to return a linked list in a nice format. So now we have implemented the add functionality. Let's also implement the search functionality now. Using this search function, we're gonna search a node in the linked list. This will take 2 parameters again, self and data. Let's change the data to key for our better understanding. Here we're gonna create a temporary variable current that will point to the self.head. While current, we're gonna first check if current dot data equal to key. If this is the case, then we're gonna just return the current dot data. Else, we're gonna move the current to the next node. And here, so this is it for the search functionality. We're gonna return none. When the value is not found, we're gonna return none at finally. Let me exit this shell now. Let's clear the screen. Let me maximize this terminal. And we're gonna type Python -i main.py. Let's create a node now. That is the linked list object. L equal to linked list. We're gonna add a node L.add. We're gonna first add 10. Let's also add another node L.add 20. Let's also add another node 30. If you see the size of this linked list, we see it returns 3. If you here L dot search, we're gonna search for 30. So we get a error, data is not defined. So we need to change this to key. So let me clear this terminal. Exit. I'm gonna run this function again. L equal to linked list. I'm gonna create the object again. L dot add 10, L dot add 20, and L dot add 30. So let me search for a variable. We're gonna search for 20. You can see we get a data node in data 20. So this is how you implement a search functionality in linked list. If you see the L now, we get a nice format of head 30 and tail 10, and we get a data of 20. So this is just a part 1 of data structure series that I have started. If you want the part 2 of this linked list series, you can comment on this video to want the part 2. So I hope I will continue this series on each Saturday. So this is for this video, and I will continue in the next one.